All right, I think you had 11. We talked about this one though, didn't we? Just BH.
Yeah.
Was it more to it that you had a problem with?
No, it was just we didn't go over it during class,
Yeah.
and I was like,
Okay. Yeah. So with that one, if you had just Googled, area of the parallelogram, they would just gave you BH, you know. So that's the only thing with that. But solving for H, that type of stuff we did do.
okay,
So yeah, yeah. But that's why I created a review. So that something like that. You know. But you were good after that, right?
yeah. It's another one where um the other one I told you about.
Was it this
This
one?
one,
Okay.
yeah.
And they want us to solve for Y. All right. X plus Y over 8. So what the other variable was on the left. Q. All right, so we have Q is equal to, and that's capital Q. So make sure you hold true to the capital and lowercase letters, equal to lowercase x plus lowercase y equal over 8. And we're going to solve for y. We're going to get y by itself. So first thing we'll do is to multiply both sides by 8. 8's cancel on the right. That'll give you 8q equal to x plus y. 8q, excuse me, equal to x plus y on the right. Then if I want to solve for y to finish it off, subtract x, cancel on the right. That leaves me with 8q minus x equal to y. And that would be it for us.
So use the clearing fractions principle.
Yep, pretty much. Yep.
Okay.
Mm-hmm.
Thank you, Professor.
Not a problem. Was that it?
I think that's it.
Okay. Okay. You know what to do if you run across another one.
Yeah, I'm gonna do the review
Mm-hmm.
one more time today, and then I'm gonna take the test tomorrow.
All right. Sounds good. All right. So this next section, 6.4. Remember last class we did a lot of exponent rules. So here we'll look at adding and subtracting polynomials. Looking for my stuff. All right, so like terms and unlike terms will dictate whether we can add or subtract our terms accordingly. If there are like terms, those are the terms that we can add and subtract. They have to have the same variables, same amount of variables, same exponent on your variables. And if they have that, then we can add them together or subtract them from each other. So 5x and 3x, 10x squared, negative 17x squared, 39x squared y, 101x squared y, and even the numbers we're normally used to dealing with, 8 and 73 terms or numbers without variables at all are like terms. So unlike terms, if anything's different in your variables, then you cannot add them or subtract them from each other. So 5x and 3, 10x squared, negative 17x, and then negative 39x squared y and 101xy. If anything's different, any variable different, any exponent is different, then you cannot add them or subtract them from each other. All right, so just similar scenarios, just to make sure we understand or okay with what we can add and what we cannot add. 5x and 3x is 8x. 5x plus 3 is already in lowest terms. Cannot add those or subtract them from each other. Same thing with 5x plus 3y. It's already in lowest terms. 5x squared plus 3x squared is 8x squared. Notice we didn't change the exponent. All we did was add the coefficients that were in front of our exponents. And then 5x squared plus 3x is already in lowest terms. All right. So before we pull out some problems, any questions on what we can and cannot add together? All right. Examples. So let's see. Directions could be add, could be simplify, could be subtract, so if you see the operation, just make sure you, I don't want to go 3, let's go 7. Here we have 7x squared y plus 20x squared y minus, just give you 8. Just want to emphasize here, what you would do is combine your like terms. That would be 27x squared y. And if you don't have anything to combine it with, then all you would do is bring it down. So that's 27x squared y minus 8. All right, so here, 3c cubed plus 5c squared minus 7c equal to 11c cubed plus c squared plus 3. So you just combine your like terms. So negative 3c, negative 3c cubed plus 11c cubed is 8c cubed. 5c squared plus 6c squared plus 11c squared. There's nothing I can combine negative 7c with, so you bring it down. Same thing with the plus 3. And that would be your answer. All right, so combine your like terms. 4w squared plus 3w squared, 7w squared, negative 2x plus 6x is a plus 4x. And then that negative 4x squared, just bring it down bottom. All right, questions, any questions? B squared. All right, so if we have a minus sign in between our quantities, then don't forget this minus sign has to be applied to each term that's follows that's in the following parentheses. So before you combine anything, make sure that even if you don't write it out, you recognize that each one of the signs in the following parentheses has to change. So that goes to negative 11p squared minus 4p plus 6. So now from there, you can combine your like terms. We have negative 4p to the fourth. Cannot combine that with anything. Then we got 5p squared, negative 11p squared, negative 6p squared. 4p doesn't combine with anything. And then negative 3, positive 6 is a positive 3. Make sure we're okay. And always remember that if it's something is negative, like the 4p, make sure it stays negative when you bring it down to your final answer. Same thing as if it was positive. All right. A squared minus 2ab plus 7b squared minus the quantity of negative 8a squared minus 6ab plus 2b squared. So just like before, minus sign in between. So it has to be applied to the parentheses that follow. Trying to make sure something. Okay, so if I wanted to rewrite this, that's a squared minus 2ab plus 7b squared plus 8a squared plus 6ab minus 2b squared. Combine your like terms. That's 8a squared plus a squared, which is 9a squared. Negative 2ab plus 6ab will be plus 4ab. Then we have 7b squared minus 2b squared, which is plus 5b squared. All right, questions on adding and subtracting polynomials. So we'll do 6.5 and then call it a day. So multiplying polynomials. All right, so multiplying your polynomials, even if you don't write it out, this is how we should be processing how we would do it. So you do 3 times 4, and then x to the 4 times x to the second. 3 times 4 is 12, and then don't forget, whenever you're multiplying like bases, you're going to add your exponents. So that'd be x to the 6. So make sure we notate the difference between adding and subtracting versus multiplying and then eventually dividing. When you're adding and subtracting, you have to have like terms. When multiplying, you do not. When you add and subtracting, your variable stays the same, your exponent stays the same. When multiplying, that's not going to be the case. Notice we ended up adding our exponents. And that goes back to our exponent rules that we talked about last class. Here, negative 4 times 2, c to the 5th times c squared, d times d to the 3rd, and then e. It's just in the back, nothing we can combine e with. Negative 4 times 2 is negative 8. C to the 5th times c squared, c to the 7th. Don't forget, if you don't see anything there, assume you know there's a 1 for the exponent. So that'll be d to the 4th, and then e. All right, questions? Okay, so before we had 2 monomials, one single term times a single term. Here we have a single term monomial times a binomial. So you would distribute. And I'll write this out the first time to make sure you're okay with what's going on. But of course, you don't necessarily have to write this out as you continue to progress throughout the course or throughout the section. But it's 2x times 4x. So that's going to be 8x squared. You adding your exponents. And then 2x times 3 is going to be 6x. And that will be it. When we start doing more multiplication, you'll see that sometimes you will be able to combine your like terms. But if there are no like terms, then you just stop right there. Any questions? Any questions? All right. So the next one, negative 3a squared times the quantity of negative 4a squared plus 2a minus 1. So once again, we're going to take this quantity, or this term, it's on the outside, and multiply to each term in the quantity. So negative 3a squared times negative 4a squared is going to be a positive 12a to the fourth. So negative 3 times negative 4 is a positive 12. A squared times a squared is a to the fourth. Negative 3a squared times 2a will be negative 6a to the third. Negative 3a squared times negative 1 will be positive 3a squared. All right. Questions on that one? All right, so here we have binomial times a binomial. So most of you, I won't say most of you, some of you may have heard of the phrasing or the acronym FOIL, first, outer, inner, last. If you want to lean on that, that's fine. Or you can just remember to take the x, multiply to each term, then take the negative 7, multiply to each term. So that's the flow that you need to consistently do, even if you don't have binomial. Let's say if you have a binomial times a trinomial, what you need to do is take each term in the first parentheses and multiply to each term in the second parentheses. All right. So x times x is x squared. X times 2 is 2x. Negative 7 times x is negative 7x. Negative 7 times 2 is negative 14. Like terms in the middle. X squared minus 5x minus 14 will be your answer. Questions, questions, questions. All right, y minus 2 times 3y squared plus y minus 5. So, same type of thought process. Take the y, multiply it to each term in the parentheses. So there's 3y cubed plus y squared minus 5y. Then take the negative 2 and distribute it into the parentheses. So that's negative 6y squared, negative 2y plus 10. Combine your like terms. 3y cubed doesn't combine with anything, but we have y squared, negative 6y squared, which was negative 5y squared. Then we have negative 5y, negative 2y, which is negative 7y, and then 10 in the back. So that will be the most simplified expression. Any questions? Here we have 2x plus 3, 2x minus 3. Once again, distribute the first term in each to each in the following. Distribute the second term to each in the following. So that's going to be 4x squared. 2x times 2x is 4x squared. 2x times negative 3 is negative 6x. 3 times 2x, positive 6x. And 3 times negative 3 is negative 9. All right, I'll make sure I'll address that test question before we leave out. It's all good. So 4x squared minus 6x plus 6x minus 9. So the negative 6x and positive 6x will cancel. That leaves you with 4x squared minus 9. So that will always happen when we have what we call conjugates. In other words, if you notice the only difference between the parentheses or what's in the parentheses is a positive and negative as your middle sign. So whenever you have that scenario to occur, those are considered conjugates. When you multiply them together, your middle term should cancel out for you. All right, so if I have 1/2 x plus 6, 1/2 x minus 6, 1/2 times 1/2, don't forget your fractional work. 1/2 times 1/2 is just 1/4. So it's 1/4 x squared. Half of 6. That's just 6 over 2, which is 3. So just showing you the work behind it. So that's 3x. 6 times 1/2, positive 3x. 6 times negative 6. It's 36. Negative 36. So the 3x's cancel. That's 1/4 x squared minus 3x. One more type of scenario you may see. 3w minus 4 squared. So that's what you cannot do here is square 3w and square 4. You will actually be missing a term if you decide to do so. This is 3w minus 4 times 3w minus 4. The actual quantity is what's being squared here. So just like if you had 3w4 minus 4 to the 5th power, you would have to write out the parentheses 5th time and expand it out that way. So fortunately, we do not have the 5th power going on here. So, and you wouldn't, I was just throwing that out as an example. So go ahead and do your binomial distribution. 3w squared should not be the answer, it should be 9w squared. 3 times 3 is 9. W times w is w squared. Then 3w times negative 4 is negative 12w. Negative 4 times 3, negative 12w. And then negative 4 times negative 4 is a positive 16. Combine your like terms in the middle. 9w squared minus 24w plus 16. All right, so the last one, unless someone needs another example of one. Same type of scenario as the previous, but we have 5x squared plus 2 squared. So that's 5x squared plus 2 times 5x squared plus 2. All right. Do your distribution. 25x to the 4th plus 10x squared. And then distribute 2, 10x squared plus 4. Combine your like terms in the middle. 25x to the 4th plus 20x squared plus 4 will be your final answer. Questions, concerns, comments on those two sections? All right. So, as always, try this stuff out. See if you get stuck on anything. You know, get to a point where you can go ahead and knock that test out. Let me know if there are any issues or questions that you have on, you know, chapter. What this is 6, chapter 4 or 5. So any questions that you have, make sure you get with me. Email me. We have to set up a separate Zoom session, you know, individually. Let me know. We can do that. Also, don't forget. Oh, and I can go ahead and talk about the testing process. It's jldavis@tcc.edu. Give him a chance to respond to you. If he has not responded within 2 days, always let me know so I can see what's going on. I know it's a lot of stuff going on, you know, just with regular happenings right now anyway. But he does respond normally in a timely fashion. JL. Sorry about that. So just type it in the chat. So JL. Yep, jldavis@tcc.edu. And also, like I said before, you don't necessarily have to come to me, you know, for tutoring. If you don't want to mess with me, that's fine. You could always go to the tutor lab, and Mr. Davis is the one for that as well. Yep, you would just ask them, let them know you're ready to take your first test. So, you know, give them my name and your section. I only have one MDE 60 anyway, so if you let them know MDE 60 for Mr. Tucker, and I'll give them your name and all that good stuff like that. he'll know what to do from there. He'll probably give you a testing schedule, and you get to pick when you can meet. Yep, no problem, not a problem at all. Anything else? Anybody else before we close out?
Thank you, Professor Tucker.
Not a problem, man. Not a problem.
I took my
Um,
video down. I didn't want to be on YouTube.
it's all good, man. It's all good.
Oh, you could be YouTube famous now.
Yeah, man. So always and thank you guys for letting me know when the audio wasn't working right. Because if ever that's an issue, let me know. If it's an issue with anything, always let me know. If there's a drag, if something crazy going on, let me know so I can try to rectify it. Because you know, I want to make sure you guys are hearing me and seeing me well. And I do, you know, want to make sure these videos are clear enough so that people can look at them later on. So outside of that, I'm good. If you guys are good, have a great weekend. Be safe, and I will see you on Tuesday.
You too, Professor Tucker.
All right. Have a good one.